What's going on, everybody? Welcome back to my channel. For those of you who don't know, my name is Adam James. I am a plastics engineer with years of experience with 3D printers, injection molding machines, and CAD engineering software. In today's episode, we are going to learn how to 3D print your own face. Before we get started, today's episode is sponsored by none other than Proto Pasta. Proto Pasta was generous enough to send out a couple rolls of filament for me to use and 3D print this facial scan for us today. So thanks again for Alex and Dustin at Proto Pasta. Proto Pasta, I highly recommend their filament. I had the opportunity to tour their facility last year, and they're doing some really awesome stuff there. Again, feel free to check out Proto Pasta. I'll leave a link in the description to their website and their Instagram. And then go ahead and follow Proto Pasta at proto_pasta on Instagram. Before I go much further, I do want to point out that this is using a structure scanner. I scaled it down a little bit. This is the first model I did, June 7th of 2019. Still looks pretty good. But when comparing it to the Bellus 3D scan model and using the Proto Pasta premium blue filament, this just looks insane. I'm going to put this 1-to-1 next to my face here just so you can look at it. But look at the detail in the nose, in the eyes, and even the ear. It's crazy. And you can see even some of the hair profile got captured as well. Hopefully this comes out well on camera. But I am genuinely impressed with the quality of the Bellus 3D scan combined with the premium quality of the Proto Pasta filament. This looks really good, and I highly recommend this process. Now, the first step to 3D printing our face is going to be to create a 3D scan. And to create a 3D scan, I typically use an app on my phone called Bellus 3D. Bellus 3D is super convenient, and it's very user-friendly. So let's get started. You'll notice that I do have some pretty long hair. COVID, pandemic, haven't had the chance to get my hair cut. I'm going to wet it behind, and then I'm going to keep this flat brim or this hat on while I do the scan and keep it backwards so that we can get the ears and that these sunglasses can actually go behind the ears and actually work on the 3D printed model. So let's just perform some video editing magic here, and just like that, my hair is slicked back and we're ready to go. So I'm going to record on my phone as well so you guys can get the perspective from me recording on the phone in the app. We're going to select full head at the bottom right, which is going to allow go ahead and use that. And what we're going to do is we need to export it. So we'll save this. Just name it My Face X. And it says model uploaded successfully, and then we want to export. It costs $1 to purchase the STL model. Super cheap. I will buy this for support of the video, so let's go ahead and do it. Purchase was successful, and then we want to export it again. We want a watertight model. We will do high definition because why not? Y-axis up is fine. Mesh smoothness, I've never touched that before, so we're going to leave it. And we want to export an STL file because that's what I know how to modify in Fusion 360. And then because I have a Mac, I'm just going to do airdrop here. And it's sent. So now we're in Fusion 360. So what we want to do once we're in Fusion 360 is we want to go to Insert Mesh, Head 3D 2. Okay, cool. That was today. Wow. Okay, looks really good. So from here, we are going to go to right click on the top and do not capture design history. Just accept it, click continue, and then we are going to modify the mesh, which we need to go into mesh at the top here, and then we want to reduce the mesh count, or the density, excuse me. I'm going to try 0.18 and get a preview here. See what this looks like. Let's just do, oh, that's right, we need to actually select what we're doing. So we'll select our mesh body. Let's click OK at 0.18 mesh density. The reason we're reducing the mesh density is to allow Fusion 360 to allow us to convert it from a mesh to a B-rep. It has a limitation with regards to the number of facets that I can process. All right, 0.18 still looks pretty good, pretty clear. You can tell that's a face. You can tell it's my face, hopefully, at least I can. So let's go back to solid body. We need to capture the design history now. All looks good. And then from here, we're going to right click on the mesh and do, oh gosh, do we need to be, maybe we have to be in not capture design history for mesh to B-rep. I can't remember. Mesh to B-rep. Okay, so do not capture design history. We have our body conversion has aborted. The mesh contains a large number of facets. Okay, so let's go back. You guys actually get to see this live, right? So let's modify our mesh again. We need to reduce the number. So we're at 0.18. Let's try 0.175. I don't want to go too far down, right? Otherwise, we kind of lose the clarity and can't actually identify that this is a facial scan, right? The lower the number of facets that you have, the less dense or clear it actually is. So that looks pretty good still. You could probably mess around with it a little more to get it even more smooth, but let's just see if this allows us to go mesh to B-rep. Let's get out of here. Yes. It's processing, so it looks like maybe it will let us do it. If it does, then we are in luck. If you guys like seeing me do this live like this and actually making some of the mistakes, let me know. Leave it in the comments. Okay, so now we've got our body. Once you see the solid body in the mesh tree, or in the tree on the left, you'll know that you can keep going forward. Before you go forward, very important critical step, right click at the top here and do capture design history. So any modifications we make going forward are captured, and you can go back and make modifications to those as we go. Now, this is a fairly complex model, so it'll take some time to actually process this. There we go. And I want to save it before we go much further. I'll just say my face updated. It's fine. Perfect. Let it save. And we're good to go. Now let's make some planes here. I'm going to hide the body so I can actually see the planes. I'll grab that, bring this plane up here, show the body again. And the only thing we want is if we click on the left view here, we want this plane to be above any of the geometry referencing your face. So we'll click OK. And we also want to do this again. I'm just going to reference this top plane. And we're going to bring it all the way down. Same concept here, just don't want it to reference or interfere with any of the neck components. Looking good. So let's select this top plane that we made and we will create a sketch. R for rectangle, just go to the top left here, and we're not necessarily concerned with the dimensions of this rectangle. We just want to make sure it exceeds the bounds of our initial geometry. We're going to go to extrude and we're going to go into our face. But we're going to click on cut. It's going to take some time here. No target body found to intersect. Now that's interesting. Oh, it's because I had previously hidden the actual body. So make sure your body is shown here with the eye, and then make sure the mesh body is not visible. So let's keep going down. Again, we're not doing a full head. You could essentially print this in a printer, right? In a 3D printer, but we're not going to do that today. We're just making a modified shape. Just try 130. Yeah, that'll do. Okay, and then we're going to do the same thing on this bottom plane here that we made. Sketch. R for rectangle. Perfect. And then let's finish this sketch. We are going to extrude this. Just extrude it up. Same idea, same concept here. You can go as high or as low as you want to. I'm just going to kind of go up to the ear here. That looks pretty good. We will select OK. So that looks pretty sick. It's kind of crazy on the back how it tries to create mesh elements based on the scan that it didn't actually capture behind my head, right? But that's okay. All right, and then we've got this, so we're just going to select this top plane here and create a circle. C for circle. Just click on the origin, this should be fine. And you kind of eyeball it, right? It doesn't have to be perfect. None of these are like critical dimensions. That looks pretty good, 146. Depending on how big your head is, this will be different for everyone. I'll make this 148 maybe. Okay, cool. Finish. And then let's hide the body. Let's sketch here on the front plane and then show this body, and I want to project this bottom surface, and I'll show you why. So P for project, then select the bottom surface, click OK, and then click front view again, hide the body, L for line. Let's just bring this guy up, and then X for construction. Great. And then I'd also like to make a point. Oh, do I have to project? I guess I have to project this circle. Project this circle. So P for project, select the circle that we made previously. Select OK. And there we've got our point here. S for search, ARC for arc, 3-point arc. Let's grab that. And then I'm going to essentially create a bowl. But what I want to do is I want for this to be at least 5 millimeters offset from the bottom, so that actually let's do 10. This is a pretty large print. It doesn't need to necessarily go that deep. And then L for line. Let's bring this line out. I'll explain why I'm doing this in a second. S, ARC for 3-point arc. Click on this point, and then the bottom of this. Oh, let's bring this up a little bit, maybe 20. Same workflow. What you want this to do is you want this to be tangent with this line, so that when you revolve it around the center axis, it becomes a perfect cylindrical feature. Okay, that looks good. I'm going to click on this and do X to make it a solid line. L for line, I'm going to create a new one from the top all the way to the bottom. Oh, and that was a construction, so make sure that's not a construction. L for line again, from this midpoint out to the center. You know what? It doesn't show that. Oh, and that was a construction line as well. All right, as soon as you have this solid feature and you can click in here and it turns blue, you're ready to go. So let's do finish sketch. Let's show, actually let's click on revolve at the top after this is selected. And then let's show our body. Click on an axis. We'll use one of the construction lines in the middle that we are using for reference. And we'll click OK. Boom. And then we've got a bowl in the center of our head, which is kind of cool. Let's do inspect, and we'll do section analysis. Click on this right plane here, and then you can see what we just did. So we've got enough room so there's not going to be anything protruding from the bottom, and you can put change and stuff in here and you've still got your facial scan. So let's turn the analysis off here. Let's show or hide our sketch, and then we're going to click on fillet at the top and create a fillet just because I think this looks a little nicer. Oh, that's a lot. That's a big fillet. Maybe, yeah, 5mm fillet looks pretty good. Click OK. Great. And then let's save this. Alright, now we're going to go ahead and export it as an STL file so that we can bring it into Ultimaker Cura. To do that, we go to the top left, 3D print, deselect send to 3D print utility, make sure your refinement's on high. You can have preview mesh selected if you want. Select our body here, or our face rather. And it gives us a good preview. I've already saved this, so I'm not going to do that, but in order to save it to a file, just click OK and save it in a location that you'll remember. Okay, so now that we've got our STL file exported, we're going to go over to Ultimaker Cura. Ultimaker Cura should be free. Once you open Ultimaker Cura, you can click on this folder icon at the top left, and then go ahead and select the facial scan STL that we modified and exported from Fusion 360. We'll double click it. We can hold right click to orbit around here, left click on the face, click on this rotate icon, and then we're going to rotate it 90 degrees. Once we rotate it 90 degrees, we're going to rotate it about the z-axis just until it lands on the platform. So I think that's a good angle. What I'm going to do now is kind of do this move icon, and we can kind of just adjust it until it snaps to the print bed. There it goes. Okay. Perfect, just barely fits on there. You can see from the shadow, there's just barely enough clearance on all the edges of my print bed. Thankfully, we don't have to send this out to a bigger printer. In terms of the print settings, I'm going to be pretty basic on this one. I do what works. I've got a lot of time here, so don't necessarily need to do something super efficient, and I'd like the quality to turn out very well. So we're going to leave the quality at 0.1 millimeters. Got a lot of comments in my last video with regards to why I didn't change the layer height to 0.2 millimeters. Well, yes, of course, changing the layer height to 0.2 millimeters decreases your print time, but it also decreases the resolution and quality of your print. So I'm willing to sacrifice the time to make this outcome a little better. So we're going to leave this at 0.1. Also, some printers don't have the capability to get up to these settings, so that's just a result of the capabilities of the machine itself, right? So infill, I'm going to leave it as 20%. I'm going to leave it as triangles too. Speed, okay. Speed, the typical setting is 70 millimeters, which is a little slow. I bump it up to 90. I don't want to exceed 120, and for the purpose of this video, I'm going to leave it at 90. I know it works, and the prints turn out very well on my machine. Maybe in a future video, let me know in the comments below if doing a print settings and experimental extruder speed and processing parameters tips and tricks would be worth watching. So that looks good. We're not going to do any support though. I already checked beforehand, but the overhang, let's see if I can get this in frame here, as it's kind of struggling. The overhang of my nose is about 70 degrees, so my printer can usually handle that, so we'll leave it as no support. In terms of build plate adhesion, typically it's on brim. I'm going to use a skirt because the amount of surface area on the print bed should do just fine in holding the PLA down to the glass print area. So we'll be fine there. We're not doing dual extrusions, so just make sure that's off. And depending on your printer, some of these settings will be different, right? And then you do want to ensure, if you have a dual head extruder, that you do have the first material selected while you have your face selected. It's enabled, and then the material is whatever material you are using. That will dictate the temperature of the bed of your printer if it has a heated bed, and then the nozzle temperature and feed rate as well. So we will leave those the same, and then we will slice this, and I'll fast forward so you guys don't have to watch it. Okay, once it's done slicing, it'll give you a readout as to how long it'll take. I know I'm going to hear about this in the comments. 2 days, 5 hours, and 45 minutes, 520 grams of filament. Wow, such a waste. Like, it is what it is, and I'm not going to tamper with it. I have the time and the accessibility to do that, so we're just going to leave it as is. Once you have this, you'll see Save to File. If you plug in your USB or your SD card into your computer, it may say Save to temporary storage file. Go ahead and click on that, but in this case I don't have anything plugged in because the print is actually going right now. So just go ahead and save it to the file, and then you are ready to go and you can plug it into the machine.
I had a great time recording this video. If you guys liked it, feel free to give it a big thumbs up. It means more than you know. Feel free to subscribe if you'd like to see more in the future, and hit that notification bell if you'd like to get pinged as soon as I release new content. Thanks so much for your support, and I will catch you on the next one. Bye.